In this lesson, we are going to look at the reduction formulae in trigonometry. In reduction formulae, as the word says reduction, we are trying to make angles smaller. So we'll be given bigger angles and we'll make them smaller. For instance, you'll recall that in grade 10, you worked with triangles like this, where you had special angles. And then you were able to find the sine of 45 degrees. And sine 45 degrees is opposite side of a hypotenuse, so which is 1 over square root of 2. And then cos of 60, you'll go to this triangle. Cos of 60 is adjacent side over hypotenuse, 1 over 2. And tan of 30 degrees will be equal to tan of 30, opposite over adjacent will be 1 over square root of 3. This is when we were required to work out these ratios without using a calculator. Of course, you may sometimes try and use a calculator and you will get the same answers. However, if you look at these angles, they are acute angles, they are small angles. Now, what about sine 240 degrees? Obviously, there is no angle which is 240 degrees in any of these right angle triangles. What about tan of 300 degrees? That could also be a problem. So what do? We reduce these angles and make them acute so that we can replace them in these triangles and then we'll work out the answer. However, to do that, we will need what is called the Cartesian plane. In the Cartesian plane, we know that we've got 360 degree revolution angle. The angle between 0 and 90 degrees is an acute angle. An angle between 90 and 180 degrees is more than an acute angle. So we will try and reduce it to an acute angle. We'll write it in terms of an acute angle. If it is less than 180, we'll say 180 minus an acute angle. If it's more than 180, we'll say 180 plus an acute angle. If it is between 270 and 360, we'll say 360 degrees minus an acute angle, and it will be easy. However, there is also one more thing that we'll need to know or remember. It's also that in the 4 quadrant that we come from previous one, which is this one here, all trig ratios, sine, cos, and tan, they are all positive. In this quadrant over here, sine is positive. In this one, tan is positive. And in this one, cos is positive. Which means in this quadrant, sine and tan will be negative. In this one, sine and cos will be negative. In this one, tan and cos will be negative. But here, all of them are positive. Now let's look at the examples to see how this works. I've combined these two things into one so that it's easier for you to see how it works. It will be better for you to also draw a similar thing like this one, which is put together to be able to work out the answers. Let's see how it works. Sine of 180 degrees minus theta. This is here. And we said here, it's sine, which is positive. And this is sine, so the answer is equal to a positive sine of an acute angle, which is theta in this case. Let's look at this one. Cos of 180 degrees plus theta. 180 plus theta, so 180 plus an angle is here. Tan is positive, but this is cos, so the answer for cos will be negative because it's only tan that is positive. So our answer here will be negative cos of an acute angle, which is theta. Let's look at this one. Tan of 180 degrees plus theta. We are there. Tan is positive, and this is tan. So the answer is a positive tan of an acute angle, which is theta. Let's look at this one. Sine of 360 minus theta. 360 minus an angle. It's there. It's only cos that is positive, but this is sine. So the answer here is a negative then sine of an acute angle, which is theta. Let's look at this one. Cos of 360 minus theta. This is also there. And their cos is positive. And this is cos. So the answer is a positive cos of theta. As easy as that. Now let's look at how they can ask you in the exam or in the test. Again, I've drawn this thing for you to make things easier to get the answers. So now they give you a problem like this one. It looks horrible, but if you follow what you've been doing previously, we'll get the same answers. Let me draw a division line. So which is that line over there. So tan of 180 minus theta. So we are there. So and there only sign is positive. So this will be a negative. So I've got a negative tan of a theta. This thing here, this whole thing must be multiplied. So I'm multiplying by this one. This one here, sine 360 minus theta, we are there. It's cos which is positive, but this is sine. So the answer is a negative, a sine of theta. Let me put it like that. So times sine of 180 minus theta. This is over there. And there, sine is positive. So the answer is a positive sine of theta. Take this one. Sine of 180 plus theta. We're over here. Tan is positive. So this will be a negative sine of theta. Times tan of 180 plus theta. We are over here. Tan is positive. So that's positive tan. So therefore, I'm multiplying by a positive tan of theta. Now we can see these are factors and I can cancel the same factors. Note, this is tan theta, will cancel the negative tan theta. So positive tan theta, cancel there, so the answer is negative 1. The negative sine theta cancels another negative sine theta, that's 1. So what is my final answer? The final answer is a negative 1 times sine theta divided by 1 times 1, and the answer is a positive sine theta. You may get 1, 2, 3, 4, 5, 6 marks for this. Let's look at another example. Remember we spoke about the angles, the bigger than 90 degrees and the bigger than 90 degrees, and that is 30 degrees. That is fine. So there's a problem with these two angles. So which means that when you've got the angles like these ones, and it's unlike the previous one where we had 180 minus. So we've got to write this in this format. This until we get something like this. How do we do this? Let's check. 150 degrees is an angle which is here. It's between 90 and 180. It's here. So I'll write that as 180 minus a certain angle. So this is same as saying sine of 180 degrees, and then to get 150 I must subtract 30 degrees. So they are the same. Come to this one. It's plus. This is 10. Now 330 degrees is over there. 330 degrees is there. So I'll write it as 360 minus a certain angle. So 360 degrees minus what to give us 330 degrees. So it's minus 30 degrees. Those is same as that. So multiplied by it. We don't have a problem with this because this is acute. The angles must be acute. So we replace it as cos of 30 degrees, just as that. Now we can do the same thing that we've done previously. So you say this is, in which quadrant is this? We are here. And then only sine is positive there. So the answer for this is a positive sine of an acute angle, which is 30 degrees over there. So plus this one, we are over here. It's only cos which is positive. So this is a negative, a tan of an acute angle of 30 degrees. Put it in brackets like that. So we said this is fine as cos of 30 degrees. So obviously you can simplify the plus and the minus over there. So this is sine of 30 degrees. Positive and negative is negative tan of 30 degrees, which is multiplied by a cos of 30 degrees. So let's check what is the answer. Now you can see now I can use this triangle. What is sine of 30 degrees? There is 30 degrees. Sine of 30 is an opposite side over hypotenuse, which is 1 over 2. This 1 over 2. So I'm subtracting. What is tan of 30 degrees? There is 30 degrees. Tan is opposite over adjacent. So it's 1 over root 3. So it's 1 over square root of 3. It's multiplied by. What is cos of 30 degrees? Cos of 30 degrees is an adjacent side over hypotenuse. So it's square root of 3 over 2. Now you can see that the square root of 3 will cancel with the other square root of 3 there. So this goes once there and that goes once there. So my answer is a 1 over 2 minus this 1 times 1 is 1 over 1 times 2. 2. So my final answer is what? 1 over 2 minus 1 over 2, which is a 0. It's easy as that. So, on your own, can you try these simple problems from your Siyavula textbook, chapter 6, on the reduction formula, 6.3 reduction formula, exercise 6.4, numbers 1, 2, 3. It would be worthwhile if you have a copy of this on your side as you do each and every problem until you get used to it.